Screws are generally smaller than bolts. They can have a variety of heads. They're used on smaller components, and often their thread extends right from the tip to the head, so they can hold together components of different thicknesses. Different screws can be tightened with a range of tools. This is an Allen head screw with a recess for an Allen key. It's sometimes called a cap screw. It usually screws into a hole rather than a nut, and it needs a small spanner. This is a machine screw. It has a slot for a screwdriver. Bolts are always threaded into a nut or hole that's got an identical thread cut inside. But a couple of special screws cut their own threads as they go. This is called tapping a thread, and this is a self-tapping screw. It's made of hard material that cuts a mirror image of itself into the hole as you turn it. This is also known as a self-tapping screw, but it's designed for cutting and holding thin sheet metal, so it's often used on car bodies. Bolts are often bigger than screws and are used for heavier jobs. They nearly always have hexagonal heads that only fit spanners, or Torx drivers for these Torx bolts. Often the thread on a bolt is only as long as it needs to be to tighten onto the nut or into the threaded hole. A stud is like two bolts in one. The exhaust manifold on the cylinder head is located and held by studs. Studs can have different threads on each end. On this end, there's one that's best for gripping the hole in the exhaust manifold, and on the other end, there's a thread for pulling everything together tightly with a steel nut. Nuts are often used with bolts. A nut is a piece of metal, usually hexagonal, with a thread cut through it. There are many different ways to keep it done up tightly. This self-locking nut can have a plastic or nylon insert. Tightening the bolt squeezes it into the insert, where it resists any movement. The self-locker is highly resistant to being loosened by the kind of vibration that engines and vehicles experience. Tightening this style of nut distorts the insert, so it only provides its locking effect the first time you use it. If you remove the nut, replace it with a new one. More secure still is this castellated nut with slots like towers on a castle. When it's screwed onto a bolt that's been drilled in the right spot, a split pin can be passed through them both and then spread open to lock the nut in place. A speed nut isn't as strong as the others, but it can be a fast and convenient way to secure a screw. Once the speed nut is started, it doesn't need to be held. Some bolts and nuts need washers. Flat washers spread the load of a bolt head or a nut as it's tightened and distribute it over a greater area. This protects the surface underneath from being marked by the nut or head as it turns and tightens down. Flat washers should always be used to protect aluminium alloy. Other washers tackle the problem of nuts working loose through vibration or movement. A spring washer compresses as the nut tightens, and the nut is spring-loaded against this surface, which makes it unlikely to work loose. The ends of the spring washer also bite into the metal. Spring washers are used more for bolts and nuts. Screws mostly rely on smaller shake-proof washers. The external ones have teeth on the outside, the internal ones on the inside, and one has both. Tab washers get their name from these extensions. After the nut or bolt has been tightened, they remain exposed and are folded up to grip the flats and prevent movement. Chemical compounds help prevent fasteners loosening. They're applied to one thread, then the other is screwed onto it. This creates a strong bond between them, but one that stays plastic. So in future they can be separated with a spanner if necessary. Other compounds can be applied after assembly. Some metals react with each other and bind together. Spark plugs can do it when they're in aluminium cylinder heads. Anti-seize compound neutralizes the chemical reaction that can make this happen, and it prevents threads and fasteners from sticking together. Larger bolts and nuts must sometimes be tightened to a specified level, tight enough to hold components together, but not so tight that the component or the fastener could fail. This level of tightness is called a torque specification. Bolts and nuts are often marked to tell you how strong they are, how much torque can be safely applied to them. This is a grade 5 bolt, as these markings show. This is a grade 8 bolt, so it can be done up more tightly without danger of it failing. The dots on this nut give similar information. This is a grade 8. These are imperial system markings. The metric system uses numbers stamped on the heads of metric bolts and on the face of metric nuts. Even studs have a marking system to make sure they're not overstressed when you tighten them.